let's start with Tankscope. We have already studied the empty diagram. If not, you can refer to the other videos. So in flammability diagram, when we are doing inerting of the tank and hydrocarbon concentration is high and oxygen is very less, at times we use the Tankscope. So this is what a Tankscope looks like. So in flammability diagram, when we are doing inerting, we are using the tank scope with very high concentration of hydrocarbon, and inert gas is we are inerting, and oxygen is very less. So this is a tank scope, we can see, which measures the hydrocarbon percentage of volume of gas from 0 to 20%. Then at 13% there is a check mark. So we have the operating procedure, yes, and we have the different switches. Let's see. So we have a selector switch to we want to put in normal calibration, or you have to start taking the gas, sample gas from the tank or somewhere. And the start stop switch, we can, for span gas calibration, there is a span hole here. Zero adjustment if this zero is not there, and voltage adjustment for the current. So we place the sample in the fresh air. Initially start, and we start in the fresh air, and then we turn the selector switch to the check mode. Then this switch we pull up and squeeze the aspirator bulb for taking in the gas, and adjust the voltage adjustment until the meter points the reading at check. So we adjust the voltmeter up to the check position. That is your voltmeter adjustment. Then we turn the selector switch to gas for taking the gas, and we adjust the zero pointer if it is not on zero, and we place the end of sampling line in the area to be tested. So we have the hose and we put in the hose. Then the main principle of Tankscope is Wheatstone bridge, where when all the resistance are balanced, then there is no current which is flowing, because the current is equal to the resistance, and there is no flow current because resistance is stopping the flow. Now in Tankscope, we use a non-catalytic filament or metal coil coating. What happens, this element, it does not it cools down in the presence of hydrocarbon gas. So we use the aspirator, which is like a bellow or bulb, like we have in the blood pressure instrument. So we pull, pump this aspirator, and the sample air is taken in, passing through the resistor, and this resistance cools down in the presence of gas. Why we are using this cooling down? Because we are using this in inert atmosphere, and the burning cannot take place in inert atmosphere. So we need a element which is non-catalytic filament, which resistance changes without any burning. So this element is a non-catalytic filament, and with temperature cools down, resistance is decreasing. The resistance is measured in the galvanometer and the flow of the current, and with that we can know the reading of this galvanometer will be changing here, indicating the percentage of hydrocarbon. So this is the use of tank scope while inerting.